Okay, recording and sharing. How's that?
Looks better. Yeah, there we go.
Okay. How's the?
We're in just regular view. It's not in presentation mode yet.
Oh, right. How's the? Are you hearing my printer going?
Nope.
All right, great. Okay, so here we go. Lab report. It is December 7th. It's just me and Earl today. I've got a few things to cover. Not a lot of slides here, so we'll jump right into it. This might be a short-ish one. Okay. So the first thing that I made a lot of, so I was at the Cages board meeting this past weekend that made for some busy times. And hang on one second here. I think we're going to pause this.
Okay.
I can't hear. Okay. So I was at the Cages board meeting that was out in Albuquerque. It was a good time. I got a chance to kind of talk to and meet a lot of the people that are doing good work in cartography and GIS.
You're in. I'm seeing your the presenter view now on my side.
Oh yeah, yeah. How's that?
There we go. Now we're playing with Legos.
All right. Okay, so I had a chance to meet these guys. Fortunately, while I was there, I got a chance to work on the pycnophylactic interpolation, so that was nice. So again, the idea behind the pycnophylactic interpolation is basically I'm working on it as a resampler. So you take a raster, you blow it up from kind of a bad view, and try to interpolate and figure what the missing values or what the values should be. So baseline comparison is with a cubic interpolator. This is kind of what would normally be done if you run like a resampling routine in ArcGIS or something else. Most of the people using things like SciPy or whatever are going to be using a cubic interpolator if they're going to be doing resampling. And this comes in to play for things like raster reprojection, which is kind of how I got remotivated to do this stuff, the stuff that I was working on with Stephanie Zick a few weeks ago. So I got to test it. Last week I presented some sort of baseline. I coded it up and kind of demonstrated that it worked and kind of visually inspected it. And this time I got to do some real quantitative analysis. So working from the top right image, that's our classic picture of Abe Lincoln. So Tobler basically used an ASCII art version of this in his original paper. I should have put this image in here and I didn't, but then there's the pixelated view of that. So if you resample every, in fact, let me,
yeah,
you and me, let's, let me throw that in there. Okay, are you seeing that, Earl?
Yep.
Okay, so
that's the second. Yeah, okay. The second one, well, the third one, I guess it is after it. Is that the one I'm looking at, or
yeah, So the Abe Lincoln, there's the kind of just the head extraction, which is what Waldo did. This is the sort of the resampling to kind of sample it down.
Okay.
And what this lets us do is make a comparison, because when we resample up, then we've got something that we can directly compare against. Okay. We know exactly what it should look like, and we can kind of see how much information is lost. And in a perfect world, we would be able to recover the exact image.
Right.
All right. So that's the piece that we're doing. Essentially, we're taking this pixelated view and we're trying to reconstruct it. So this result down here is the cubic result, and it is, it's okay. It's blurry. It's a lot better than the original. But what we can do is we can do a comparison. So we can take the original image and we can basically subtract the cubic interpolation, and we can do root mean squared error on it in exactly the same way as we do root mean squared error as everything else. We compare the pixel value, we calculate the difference, we square it, we add all those up, and then we take the square root of that. And that gives us a measure of quality. So what you're looking at here, the RMSE statistic here is sort of like you could think of it as kind of like a mean pixel difference. And it's not really a mean pixel difference because we're squaring them. But it's something like that. The results kind of don't worry about the median image here for just a second. I'll talk about that in a second. But basically, the way that the pycnophylactic interpolator works is that it iteratively makes improvements. So it goes through a first pass and it tries to figure it out, a second pass, a third pass, and you can run that a number of times. So on the very left side here is K is 5. That's 5 passes through the image trying to reallocate pixels and smooth things out a little bit. The root mean squared error for a cubic interpolation, which doesn't have iterations. So that number is the same throughout. It's just like a single interpolation pass. There are no further improvements that can be made. That's 5,393.52. So as a compare, or the blue bar, in other words. Now, as we're trying to search around the neighborhood to smooth things out, one of the cool things about doing this in Python is that there are a number of existing smoothing kernels that we can use. So essentially, we're doing a sliding neighborhood operation, and we are basically either taking the average of kind of a neighborhood of pixels, and I think for all of these I used 9 or 11 pixels. So what's the average within a 4 pixel radius or a 5 pixel radius? You could use a Gaussian, which is sort of the weight of that pixel's influence diminishes with distance, so kind of a traditional distance decay model. Or you can use a median, which I was really excited about because everybody knows how excited I am about nonparametric statistics. So essentially what we have moving left to right on this image is 5 passes, 25 passes, 100 passes, and 500 passes through the smoothing. And so what you see for everything other than the cubic, because that's not iterative, you can see those percentages dropping. Not significantly, right? So if you look at the mean, after 5 iterations, we've gone from 5,270 to 5,268, and essentially it flatlines at that point. The Gaussian goes from 5231, 5205, and that's about where it flatlines. The cool thing about the median is that there's significant improvement at each iteration block. So at 5 iterations, it's worse than any of the methods. But by 25 iterations, it's better than any of the methods. So we're able to reduce error down to 5,067, which is better than any of the other kernels and better than any of the interpolators. And the upper image, the graph up there, this is a graph of the root mean squared error by iterations. And so basically you can see that the error drops very quickly. And so by about 20 iterations, you've hit, and in fact, almost by 10 iterations, you've got all of the gains that you're likely to get. So that's interesting because that means that it doesn't necessarily have to be a time-intensive process, right? There's really no point necessarily in running it 500 times. Even if you run it 25 times, you're getting a very good result, and that happens pretty quickly. So that was cool. Now, what are the implications of this? The implications, I think, are pretty awesome. So what we've got here is an interpolator that's better than the standard use interpolator, right? If people are interpolating anything, they're using QBIC. And if you look at all the Esri documentation, if you're looking at most of the scientific papers you're going to read, if they're doing resampling or if they're doing projection, they're almost always using a QBIC interpolator. And so what we're demonstrating here is that you can actually get substantial gains using pycnophylactic interpolation, which is pretty awesome. The other thing that I think that this demonstrates is that we've got a situation where, so the alternative is kriging, right? So kriging is kind of considered the gold standard for interpolation in a geographic framework. And Enki Yu has a paper with some other people that demonstrates that essentially the mean kernel operates almost exactly like kriging. And if we can demonstrate, this is sort of next where we're taking this to the next level here, but if we can demonstrate that a median kernel actually provides improvement over that, that's something that kriging is almost fundamentally based on parametric statistics. And so we've got a real avenue here for putting out an interpolator that performs much, much better. Now, the last thing that I want to point out, though, is that the median interpolator looks weird. So this is where we're looking at Abe Lincoln at the bottom here. This is the result of one of those pycnophylactic interpolations. And it's really different, right? There are bigger discontinuities. But on the other hand, it is preserving edges. So if you kind of squint your eyes a little bit, the difference between the QBIC and the median, I think, is interesting in that the median does really preserve some nice things like the hairline, right? So Abe Lincoln's hair has a sharper boundary in the median pycnophylactic interpolation than it does in QBIC. So when we're talking about interpolating things like elevation surfaces in really highly discontinuous places like cities or mountainous areas, we may be able to produce a better result with a median interpolator. So the next big step is obviously trying this out on terrain. So it's all well and good to try it on Abe Lincoln, but we'll have to try it out on terrain. And I think having, well, we'll talk about this in a second here.
Question, can you go back 1 second? What is the actual pixel counts of the images? How does that work out? Is it the same amount of pixels or?
Yeah, so the original Abe Lincoln, I don't remember how many pixels there are, but I think I decrease it by a factor of 8.
Okay.
So basically, we're not resampling every 8th pixel, but we're basically finding the average within an 8x8 block of pixels.
Okay.
And then so the bottom ones, the QBIC and the median, are essentially putting back those 8 8x8 pixels. So this is like a 1/64th resolution because it's an 8x8 block. So we're only keeping 1/64th of the original data, which is pretty amazing. And so this is trying to reflesh that back out again.
Okay, so it is trying to put it back up into the same basic original pixel counts then.
Exactly. Yep.
All right, that's what I thought. I was just trying because you can sort of see some of the blocky structure left in it, like around his ear, and so it's actually like looking like the pixels in the downsampled image. So I wasn't sure if that was.
Yeah, and I think that probably has to do with sort of the relationship between, and I haven't worked all of this stuff out either yet, but the size of the kernel I haven't really played around with much.
Okay.
I think I know that on a mean kernel, the bigger the footprint, the more quickly information is going to spread, and the smoother it's going to get. But I haven't really figured out what the balance point is there. So that'll also be
weird because you get the really nice smooth edges along the hairline, but then you had those big blocks of pixels, and I'm just like, huh, that just sort of
And I mean, and I think that that's the interesting thing. Amazingly, that is actually, quantitatively speaking, that's a better result than the cubic.
Yeah.
So that's interesting, and I think it's the difference between getting the big things right and the small errors. And there could be a, you know, another thing that could be true is there could be a ceiling effect here, because this is a bounding, you know, this is 0 to 255. So you can't make, if you're at 0, you can't really make errors under 0, and if you're at 255, you can't really make. So that's interesting. I hadn't thought about that. That's there could be a constraint problem here that might be artificially inflating it. But we'll know more when we try it out with the SRTM data. So let me talk about that here for a second.
Okay. Yep. Sorry.
Oh, that's good. That's good. I'm going to see if I can turn this other TV off, because I'm getting my audio coming out of the other TV, and I really would prefer it to come out of this one. All right, can you hear me?
Yeah, sure can.
Let's see. How about now?
Yep.
Okay, perfect. Yeah, still kind of learning the.
A little echo now.
A little echo. Oh, interesting. Okay. Okay. So so the other big thing that I've been working on is the RU manuscript. I actually made some pretty good gains on this in the past 2 weeks. So I thought it might be helpful. I was thinking about like.
Just so you know, you're not in presentation mode yet.
Oh yeah, that's right.
Nah. There we go.
All right. The manuscript is, or that, you know, it's not really a manuscript. It's really kind of a, I mean, I guess it is, but I'm up to 2250 words. My thinking for this and for your thesis is maybe we can track number of words and kind of use that as a, you know, when you're thinking about these big projects and how to, move this over here. When you're thinking about these big projects and how to manage them, it's, you know, 8,000 words is a long way to go, and it's kind of important to kind of give yourself motivation as you're making progress on that. So we'll see how this goes. I'm going to put a bar chart of my number of words and update, you know, as we go, and we'll sort of hopefully see that thing reach an 8,000 word manuscript at some point. Just an idea. I do that when I write my papers, by the way. So I don't know, maybe something to try on your thesis, see if you like it. Okay, so one of the big things that I've been working on is the ground sampling distance. So this is just a little piece, but it's kind of one of these things that, you know, I've known about intuitively and not really paid attention to the calculations. Last week I talked a little bit about how the Pix40 and another web version of this were providing wrong results. So I went kind of back through and kind of did the hand calculations myself. And the big concern that I had was our drone was, the camera was oriented differently on the Iris versus the BusyBee. So on the Iris, the camera is kind of oriented horizontally. They're both pointed down, but you know, if you panned it up, the horizon would be on the long edge of the camera. But on the BusyBee, it was attached, basically the body of the camera was parallel to the battery, which means that it was sort of vertically oriented. And what with our discussions a few months ago about side lap percentages and recommendations for those, you're using 80%, right?
Yep.
And I was a little worried about that, like trying to figure out exactly what that was for the BusyBee, because I think we had programmed it for maybe 70% overlap, but that would have been assuming it was horizontally oriented, and like if it was vertically oriented, then like how far does that push our number down? So I went back and did some ran some numbers on those, and one of the things I did was take basically make a tower mission at 400 feet, at 200 feet, at 100 feet, and just measure the distance between the intended route to see how long tower was programming those widths.
Okay.
So if I tell Tower I want 80% side lap for my GoPro 4, how much side lap do I actually get?
Okay.
And so I ran those numbers and got something. These are in the spreadsheet here. If I program Tower at 80%, it's giving me a distance of 55.1 meters. And essentially the numbers that I have suggest that the side lap, when it's horizontally oriented, are actually about 87%. And if it's vertically oriented, are 78%. So long story short, when I tell Tower I want an 80% overlap, it's going to give me about an 80% overlap with the camera vertically oriented and 90% if it's horizontally oriented. So Tower is conservative in its estimate. So that means I'm getting at least that much overlap when I do it. So that was a bit of a relief for me. That means that we're not going to be dipping down into very, very low rates. The other thing that I had calculated out was the time. We had programmed the camera to take a photo, and I can't remember whether it was take a photo every half second or take a photo every second. But when we flew at 400 feet, we would only use every 4th second in the model reconstruction, because we know we're flying higher, we know we have a bigger footprint, so we figured that would work out. Again, that was kind of a guess based on experience and how things have been going, but I didn't actually know what those numbers were like. So I ran those numbers, and essentially what we're getting is this table down below. So at a 4-second capture delay, we're getting an overlap of 95% or 90%, depending on which way the camera is oriented. So we're probably overshooting on the overlap at those numbers, which is good, right? Better over than under. So that was nice to get kind of reassurance about that. In the meantime, I've been still downloading the Aster GDEM2 dataset. So this is from the NASA website. It's like a 250 gigabyte bunch of data. The first bunch that I got, I downloaded the zip files and then found out that the zip files wouldn't unzip. So there's some kind of corruption issue with those. And anyway, now I'm re-downloading it as not zip files. So
what were you using to unzip? Just anything? Or
I used 7-zip and I used the Windows unzipper, and they both failed out pretty hard. So yeah, that's a bummer. I've had some other problems with giant zip files before, but I don't know what's causing it. Anyway, I'm just downloading the whole thing again.
Okay.
It's all happening at the school, so it doesn't really hurt anything. Okay, so I guess I talked about the Tower flight planner verification beforehand. I did this whole slide backwards, but that's okay. Last week, I had mentioned that while I was browsing for the GDEM2 dataset, I happened across the GDEM3 stuff, which I hadn't even heard of before. So I sent them an email. You can't really download it, but I did send them an email, and they sent me this back saying, yeah, we haven't released it yet, but here's a provisional one. So I have the URL for the whole, what's likely to be the GDEM3, and so I'll probably set this to download over break as well. I don't think that I told you about this, but I had my geovisualization class working on a 3D printed model of Virginia.
No, I know you were talking about something. I didn't. Oh wow.
Yeah, it's big. I had to take a break. I'm also printing one for the whole U.S., but I had to take a break from that to get this done. It's been a slog. Things have gone pretty well. I had a couple of issues where the students had a rescaling. I had a scaling issue, so they were submitting models to me that were too small, and so they wouldn't match up. But overall, things have gone pretty smoothly. The whole thing is going to be bigger than a meter. It's clearly taking up a big chunk of my desk. So yeah, I'm hoping this will be wrapped up within the next couple of days. Get a good photo of that.
Looks much more interesting than the Illinois state.
Yeah.
I was thinking about doing a big one from Illinois, and it's like, nice little blocks. So
Flat. Yeah, Illinois is super flat. Yeah, this turned out pretty cool. Some interesting features. Most of the eastern part of the state is pretty boring, but the mountains are cool. And then I saw that Martin Eisenberg had posted this on the LAS Tools page. I don't know if you've heard much about this, but this is a space-based LiDAR system. I think just launched. I don't know when they're thinking about actually distributing data from this. The purpose of it seems to be measuring and monitoring forests, but as near as I can tell, it's going to be shooting data, or it's going to be pulling data at everything. And there was one little line in there about topography. So I think what we're looking at here is space-based LiDAR for real.
Oh, fine. Let's see. Get it.
That'll solve some of the temporal problems with LiDAR. Instead of counties having to pony up the money for LiDAR themselves, we'll get a global LiDAR data set.
Did you happen to see any resolution data in there?
No, I didn't look too hard. I just kind of wanted to share the news.
It says high resolution laser ranging, so we'll see what they do.
Yeah. Okay, so that was a pretty solid week for me, especially making some good progress on the REU report and the picnoflactic interpolator. I didn't get GDEM3, but I'll get that downloaded, and GDEM2 should be done, I think, within a day. I need to finish printing the states over break. I'm not sure what we want to do about lab reports over break. You have feelings about that?
I think for the most part, I should be available most of the break. So I don't know. I'm always cool with keeping on going. I don't think there's really much I'm going to be working anyway. So.
Okay. Yeah, it's a good motivator for me. So if you're cool with it, then we can kind of form the core. And
yeah.
It looks like I'm going to be advising Hudson. So we should see Hudson in here a little bit more regularly.
Oh, what about that student that sent me an email, the prospective grad student? What is it?
Oh, yeah. I forgot I gave him your email address.
Yeah, he sent me an email, so I sent him back saying, oh, you are a terrible person to work with, and you ride you like a beast, and yeah, so he's probably running scared.
Good. Cool. Oh, and then next week, I'm going to be working with you, obviously, to fine-tune the tree measurement protocol, and you'll talk more about that. Okay, that's it for me.
Yep. Okay, let me pull mine up here.
It was pretty cool to find out that we can give you control of the of the slide. That was news.
Let's see. Okay. Take control here. Not a whole lot, seeing as we just talked yesterday. I thought I was just putting something together because I wasn't sure who was going to be joining us today. So let's see.
Even if it's just us, it's still good.
Yep. Well, haven't really done much else. Let's see. All right, you seen anything?
Yep.
All right. So yeah, there's only a couple of slides I just wanted to say because, as you know, the whole focus of my existence for the last week or two has been the proposal defense. So that was Goal's proposal, and defense is done.
Is that Shawshank Redemption?
Yep. After crawling through a whole world of, it's like, and then, it's supposed to be a GIF. It's not going. So, well, that was supposed to be fireworks exploding, like, yay, happy, happy, happy. But for those of us that are going to watch the video later, this is one of the things that Dr. Peel and I talked about. This is my timeline of completion. So we're going to try and keep tracking myself. Well, as a motivation for myself, we're going to track my timeline in the presentations for everybody to take a look at. So I submitted my proposal already, and this past week on Monday, I guess it's this week. Oh my goodness, I don't even know days anymore. So Monday, I defended it. There is a video of it, I believe, that we are going to post up for everybody to take a look at if you wish to see it. It's a little bit long, but I went through and explained everything, and I would appreciate any feedback. Criticisms are wanted. If you see something that you do not feel is explained well enough, please tell me, because I will have to do this again in about 6 months, and there'll be a much wider audience, and I'll be trying to explain things even better. So all the advice I can get would be helpful. So coming up, since it is going to be the break, and this is our last week of classes here, I guess you guys are done there. Well, over in BT, you're done. But we have, this is our last week of classes, and next week is finals week. So today is actually reading day. Yay! And we've got a proposal. We have a defense that Dr. Pingle is going to be sitting in on for his committee, and we'll be watching today. So what I want to do now is I'm going to try and get out and start.
That's at noon o'clock your time, right?
Noon o'clock my time, 1 o'clock your time. So a little over an hour from now.
Okay.
So I've got a couple things that we're going to try and get done over the break here. The big thing is I need to go out and get a newly field sampled set of trees. We're going to try and go out and get about 50 trees over the break, and this is basically to one, retest the sample set that I already have, but two, maybe get some growth rates for trees in my new section. If you watched last week, my presentation, I tried to run through most of this for you, so hopefully you will have an idea of what I'm talking about. If not, the last sample set was taken a couple years ago, so we have to allow for some growth rate in the trees. And so hopefully by going out, one, I'm going to have a baseline to do some early sample testing, and two, I will have a variance rate to consider when I'm resampling the trees now. So that's what I'm basically going up to. I need to actually go out and drive the city and look for any discrepancies from the ground level that I can see in major tree removal or just things that do not fit the data set that's as it states now. I'm signing up for my Part 107. Hopefully I'll get that done before Christmas so I can have a nice Christmas surprise and be like, woohoo, I can be a professional pilot then. So that's where I'm pretty much at right now.
Cool.
We got a lot of work to do over the break, so I hope everybody else has some time to enjoy themselves. I will not. Well, it's going to be enjoyable. I did bring in one of the things that we've talked about several times over in a couple different proposals is trying to get the point clouds working in 3D. So I've got my Oculus Rift. I'm going to actually be playing around with that over the next couple days here in the lab and see if I can get it running.
Cool.
So that's about where I'm at. And
so on the 50 trees, what I would do is just go through like 2 streets, one street in a new neighborhood and one street in an old neighborhood. That's going to make it really easy to digitize. We'll just be able to kind of jump from one to the next. So yeah, that would be my advice. And don't worry about the exact number. It doesn't have to be 50, but just like one run of new and one run of old. And
yeah, I'll try and balance that out. So there's not much else for me to present this week because literally that's been my focus of the life right now. So goals, proposal, it's got a green, yay! Proposal is in, done, and defended, and as you still see me sitting here, it means it actually went well and I was approved to continue on with my research.
Speaking of that, did you get the form to sign?
Oh, no, I'll do that since we're done here.
Okay.
I was trying to find something online. I didn't see anything so I'm going to go talk to Dr. Ryan and ask him what the form is for that, because I keep coming up with other department stuff, like the one I had for, what was that, sociology, that I had already filled out.
It might be something to get him to update the department website on. It might not have ever gotten posted.
Okay, so proposal, that is taken care of. So coming up, I do have 2 final projects that I have to finish over the weekend. I actually presented my preliminaries on one yesterday, and I've got another one I have to present on Tuesday coming up, and then I've got to turn in the papers to go along with those this week. So that is going to be my big focus over the weekend and for the most part next week. Then I plan to try and contact the city of DeKalb because there has been some work done on the tree data set. So I want to try and get their updated data from that. I'm going to go out and try and do my field samples for some trees. Then I want to talk to Trelk. I can speak here. I want to contact Dustin to talk about, how he went about some of his work and sort of keep him in on the loop since I am working off of his previous work. And like Dr. Pringle feels that it's probably going to be a good idea. He might have some advice and a couple things for me. So.
Do you have his email address?
I don't know if I have it. Why don't you send that to me? If not, I thought I did once. I think it's still in the system. It's his email address at what, the USGS or no? I've seen it. If you could send me one to save me some time looking for it again.
Okay.
So that's pretty much it for me, everybody.
Cool.
So, all right, let's stop share.